Back in episode 75, we took a look inside one of these Phoenix Contact Quint-Power 24 volt 10 amp power supplies, and this is what we found. Some good stuff. Now, in episode 115, we're going to look at this really big Quint-Power 24 volt power supply. So this one, it's from the same series, Phoenix Contact, but it's got a 3-phase 400 to 500 volt AC input with a bung terminal, and the output is 24 volts 40 amps, so quite a bit more powerful. It's about a kilowatt. I was rummaging around in the scrap bin and dug this out, so I thought that seems like something good to have a look inside. And I don't know if it works or not. I don't have a 400 volt supply here. Presumably it was thrown out because that's been damaged, or it was thrown out and that occurred while it was being thrown out. I don't know. Anyway, that doesn't really matter. What matters is we're going to take a look inside it, and we're going to do a little bit of comparison to see if there's any similarities or not between the other single phase one. Just for fun, I guess this is going to have some kind of 3-phase active power factor thing on it. Not sure, I've never looked inside a 3-phase version of these power supplies before. Taken apart plenty of single-phase ones from different manufacturers. Let me know if you want to see what's inside this sized version power supply DIN rail mount from other manufacturers. Tell me and I'll get some out and we'll take them apart. I think I've got up there boxes of these power supplies from various manufacturers in various states of disrepair. Alright, that's just the DIN rail bracket. Yes. So let's see, the other one had the screws under the label, which was a bit annoying to make it hard to open. Guess, well, just because the stick is that size. Anyway, it doesn't look like it's the case on this one because it's bigger. Need to have some careful circuit protection if you're powering a whole bunch of stuff from this size of power supply. Need to properly distribute the power and yeah, use individual circuit breakers or fuses to get a sensible fault capacity before it enters small equipment, because this has the boost mode on it like what we saw before. So it says there 40 amps nominal, can boost to 45 amps, which I presume is continuous, and can boost to 200 amps for 12 milliseconds for the fuse blowing capability, so that it can deliver enough fault current to clear circuit protection without shutting down. Because if you're powering a lot of stuff off this, you don't really want it just shutting down when one thing gives up, or one little thing gets accidentally shorted out with someone's careless screwdriver. Okay, the cover's off. Now, unlike these small power supplies where the inputs and output terminals are pluggable types, even those ones are, as you can see on that. This one seems to be just permanent. I wonder if is that why that happened? I don't know, it's weird. You see there's a wire with sort of half-eaten ferrule in there. I wonder if they were trying to remove it from something and that terminal is damaged and they couldn't get the wire out, so yoinked it really hard, evidenced by that bit being flared up, and that broke the terminal block off. Guess that's a possibility, and then because of that it just got scrapped. So it's possible there's nothing actually wrong with this. Okay, I'm just going to undo all these screws from the side, and these side plates should come off, I think. Interesting, there is some Phillips screws there, and that one's reamed out. So maybe someone tried to open this before? Interesting construction. I'm wondering what will come off if we undo this. because down both boards on the sides have got devices on this heatsink at the back, so we have to remove what's holding those on. It looks like it's just these end insulated brackets holding devices, or holding a sub heatsink down to the main external heatsink. Yes, and we've got heatsink paste juice everywhere, so that's good. And fiddling around here, get into it. Interesting screws here, they ramp this steep angle on the threads, so they really go in and out of the plastic really fast. T whatever number screwdrivers, then these stupid interchangeable bit things that are real tedious. Okay, so the other one, it's the plate, the heatsink sides is just one piece, you see, shaped like a U bend. Whereas this one, it's a separate piece on each side. And it looks like, oh no, it doesn't, I thought, oh yeah, there is. Some parts are thermally attached to it, but not much of it. Oh look, there is a screw under the label. Oh, so someone must have been in here before. Okay, yeah, so maybe it doesn't work. If someone has undone that. They've done the roll up tight. That's some import stuff, isn't it? No idea. Need to get it apart further to determine what that stuff is. I think that will come off though. Or will it? Ah, look. There's some middle, some like high current contacts. That must be the output then. Or is that the AC coming across? Could be the AC. We need a smaller screwdriver now for those. It's interesting, they must have had, is that an OSP finish on the board, because it's gone bad. It's not like an ENIG or a Hassel solder plating on the copper. It's something that's gone bad. It's probably OSP. Okay, look at that, it does come out. OSP finish, maybe? That's tarnished. Oh, look at that. So unplugged this board here. Made a loud noise. That board there, which went into headers down there. And then this board comes with it, because I think it's, yeah, there's a header strip there that's soldered on. And then headers there. So it looks like, you know, various feedbacks and control signals of optocouplers, some kind of pulse transformer, maybe gate drive, or I don't know if that's a CT, I don't think so. And a whole bank of capacitors. I can't see the rating on them. I guess that would be output, wouldn't it? Okay, we'll take the other side off so we can get a closer look at this stuff. Okay, I think we need to undo that as well. There's something screwing into the bottom of those transformers. Yeah, that'll be the actual switch mode, won't it, with the primary and these bar or plates for the secondary high current. So that stuff there must be the power factor booster stuff, inductors, and that. Look at that, there was a bunch of, oh, that's on the old one, the old one, the previous one. I'm just looking at those plates there, copper plates to conduct the heat from those devices and from the transformer core. And good, thermal paste everywhere. Guess we should try undo those screws, the Phillips screws in there as well. Okay. Back part comes off. Quite a lot of a thick pad thing, thermal conducting pad. Now, will that come off? Did I get everything? Yeah, that should just pull off. I think the bit where it's conducting from the transformers is a bit stuck. Get a persuader. It's acting very attached. The transformers are loose. There aren't any more screws that I can see. Oh, look at that. I see what's happening. It's a very cunning thing here. These things here, the center of that is part of this. So there's bits of the heatsink poking up through holes in the board, and then it's got devices clamped to each side of it, and then the screw in the top. And there's also one there. So we have to get rid of those before we'll be able to get the plate off. That's a cunning way of joining the TO220 devices onto the heatsink. I thought there was just a floating bit of aluminium in there. That one there, that doesn't have a screw. Oh, because it latches into a hole on the other side. Okay, now these will need to be like pulled off the surface. So it's ceramic thermal conductive thingies. It's quite a lot of paste on these. Well, quite a lot is squidged off the sides of them. I don't know how they apply that. Kind of haphazardly. You see it all like juicing off the edge there. Alright, look at that. Falls off easy now. Cunning way of assembling it. But that's... I see. So that's a die cast part, isn't it? It's not an extrusion. I thought it would be an extrusion in that direction, but no, it's die cast. So that's why it's got those little bumps there from pins and things in the mold. Die cast aluminium plate. They all are. And see, it's got those pinhole things. Ah, okay, but the other side was just a flat aluminium plate. Alright. Now this thing also wiped all over the paste, so that's dirty. Okay, and there was bits. Oh, you see there's raised parts in this as well, which are squishing that. But what is that? Is there stuff underneath here? It's interesting. It's capacitors. See, the ceramic capacitors. Do you think those are high performance capacitors that need to be heatsink? Kind of weird. Guess they do a lot of work. Ultra high performance ceramic capacitors. Maybe this thing's switching at megahertz. Guess it would be to get kilowatt through those little transformers there. To see, it's got these presumably FETs with little controllers for turning them into a rectifier. Whatever you call that, a synchronous rectifier. Got good creepage on all the stuff. You can see there a transformer and its windings come right out, so that there's a good creepage. So presumably those would be nice like triple insulated wires on the windings. There's just one bit that's poked through. There's with the dimple on it. Right, we got the bits out. Now can we work out what it does, or what they do? Oh, okay. So it's not that complicated after all. It probably would have worked on like 220 volts as well. So there's the 3-phase input terminals there, and neutral. Wonder if you need the neutral. Shouldn't. Oh, it doesn't have a neutral, it's a ground. Yeah, so it's just 3 lines in, and then a ground terminal. Oh, and that's the one that got stuck. Weird. You can see that there, 3 inputs goes to the edge of PCB, and that PCB contains filter capacitors to ground, so there must be Y caps, pill core brand, 1 mic X2, okay, so they're not to ground. Oh, I see. So there's 3 terminals, but the ground is also there, so there's 3 caps which will be in a like delta configuration across the lines for suppression. They got discharge resistors on the back there, you can just see surface mount resistors there, which will be, what the value is, 1004, so 1 meg. And there's also another tiny little cap there, so that will be like star to ground. Okay, they're not in a delta configuration, they're in a Y configuration or star configuration, and then the Y cap off the star point to ground. That's how that works. The suppression. Then there's a gas discharge tube, gas arrestor. One of those, and that's off of the star point of 3 VDRs there. Those will be VDRs, and then that goes to ground. So that's for like surge arresting lightning strikes. Surges on the incoming supply cause the VDRs to start conducting, and then will break down that gap in that thing, which will suppress it down to ground. I suppose, do they have to do that because when the VDRs go bad, you still need to have that, which will effectively isolate it, maybe? Then, got it in here, it's just a full bridge rectifier, but it's a 3-phase one. So it's got 3 input terminals, 3 AC terminals on it, and 2 outputs, the DC output. So that's just effectively like 3 half bridges of diodes, or a full bridge rectifier and another 2 diodes added on for the extra phase. Then there's another type of VDR, and then another type of VDR, big fat one there, clamping off of the DC side, I guess. I'm not sure. Common mode choke. So now at DC now. Common mode choke, and that's when it goes onto those little bus bar terminal thingies. So that's where the incoming DC goes. So that hops onto this board, this side. This is double stacked common mode choke type deal there. Or was that a CT? Maybe it's a CT, I don't know. It's kind of weird. More VDRs. Pretty sure those are VDRs, or are they capacitors? I think those might be capacitors. It does say Y1 500 volt AC. Okay, so that's some Y caps to ground, high frequency noise suppression. Then that's the input cap. Trying to read the value of it. I ended up ruining it by scraping it. I wanted to see, it's not 65 microfarad or 68 microfarad, is it? It must be 0.68. There was glue covering it, and I scraped the writing off while scraping the glue off. Alright, so there's a cap, suppression, then you see there's a printing or writing. The absence of solder mask to make writing in there. So they say P-GND, power ground, and P bulk plus. And feel like it comes off of that DC there. There must be the boost converter part joining into that somehow. Not sure of that arrangement. They're just glued down, and then the windings come out on those leads. There's a link, which might be a shunt rather than a link. And we're not going to be able to get to those devices to see what they are easily, because they've got clips that have been pressed into the channel of the heatsink, holding them, and then the heatsink's soldered down. Oh, look at that, we just bend it out of the way. Not very good for it. Well, I don't think we're putting this back together, so I guess that's fine. What do we have on there? Diodes and other types of FETs. The 2-legged ones will be diodes. The 9R340C. That must be the FETs. And there's that big one, which says H30R1602. And then there's another small one, P3N150. The diodes are Cree. There must be good ones then. And it's pretty interesting that that sensing stuff there, or the feedback and control stuff, the tracks just go into where those caps are and come out the other side with minimal creepage. Makes me think that these are low voltage caps, but I don't know about that. They seem to be associated with the DC bus part. The problem is they're taped, all taped together and glued together. See if we can separate that. Ruin a good capacitor. 120 mic, 450 volt. So that's main DC bus capacitors. So that must be all DC bus capacitors. That must be in series. DC bus ground plane, DC positive. Or is it the other way around? Yeah, it's the other way around. So negative and positive off there. All that is positive. And quite insane, all of it goes through one pin on that pin header. One pin. And the other side goes through another pin. That's bizarre, isn't it? Just one pin on the pin header. So I wonder if it's a multi-stage thing. Is that just a filter and that's the PFC boosting inductors? Probably an interleaved design with the two working together. And they end up creating a DC bus voltage of presumably around 800 volts going by those capacitor voltages. Interesting little transformer thing. There's three optocouplers going that way and one coming back. Guess it's some fault feedback and some control modes. Maybe this has like different levels of operation depending on the load, so it can put it into a different state. And it's possible that there's two converters here. Well, it's obviously because two of these must be one for each of these interleaved converter, and then probably this big fat one to do with this. So possibly it runs on one of them at light loads and switches to the other one on high load. That's my assumption without bothering to try and trace out the circuit and work out what it actually does. Makes a high voltage DC and draws a nice sinusoidal current from the AC as to not have a bad power factor. And then that ends up putting that high voltage DC straight onto there. So this works the other way around to what we thought. Is that true? That doesn't make sense, does it? I got that round the wrong way. Yes, I got that round the wrong way. Yeah, the high voltage DC comes into here. There is that thing. Is that a shunt? It might be like a gate drive power supply. See, there's slots there. Oh, so that insulating sheet went into it. Oh, there's more to it than what we looked at, because we've got that there's this piece also connecting across to there and there. So there's actually multiple paths in this thing, because that header there coming back from this thing brings power into this area and has no connection to this part, which seems to only come from that little 2-pin header. And then there's some writing on the bottom of this. That was the tip off. So you can see there it says AB, whatever that means, P bulk plus, buck out minus, and res caps. Res caps. Are those the res caps? Right, resonant capacitors. Okay, guess it's a resonant converter somewhere. Okay, so the gate drives come across those transformers, because you can see coming across the transformers, those tracks come out to there, and then on the other side it's just a bit of like pulse shaping and maybe buffering before going into those things, which are presumably some grunty FETs. 43NM60D, I think that's what it says. Quite hard to see. So the layout of that's a little bit confusing, but somehow the high voltage DC gets down to this area. There's a bunch of FETs. I should say half bridges driving these which has a single primary made of 2 windings in parallel. Doesn't look like a huge number of turns. It's multi-layered. That's pretty interesting. You can see there that one, so that's two windings in parallel there. That one goes to the outer edge and one goes to the inner edge. So I think there's 2 layers of primary. And then similarly, on the secondary, see there's two bars come out and one like flicks. And one of those bars comes out off the surface and the other one comes from deep. And that flex cable was possibly halfway. So the transformers will be driven in both directions, and then there's a rectifier for each side, and then those are probably interleaved, so it's doing everything at once. So that must be, which will mean that they don't need much output capacitance, because there's a lot of switching going on. There's no waiting around for the next switching pulse, because the next switching pulse is already happening on the other transformer. So those little SOIC8s there will be synchronous rectifier controllers, which will sense the voltage and then drive the FETs to act like ideal diodes. Then there is some kind of capacitor in some heat shrink sleeve. The glue that they've used to hold this stuff down is pretty bad. It all just cracks off. It's barely glued down. Just touch it gently and the capacitor lifted off. Similarly, when prying these, they just pop out. So like that, the glue just flakes off. So maybe the capacitors have got a slightly oily surface. That's possible. Or this glue is just not really the right stuff. A little bit dodgy, because this is supposed to be vibration, hardening it for vibration, helping it to resist vibration. But if the glue just flakes out easily like that, it's not really going to help much in a high vibration situation, because soon enough they'll just rattle themselves free. It is nicely done though, because you got to consider the body of capacitors. Even though it's got that sleeve on it, it still has to be considered live on these high voltage caps. So they've taken precautions against that by putting this like Nomex or similar insulating sheet down the side there, so that that track on the top surface can't come anywhere near the capacitor bodies. And it also goes underneath, so that it's insulating the bottom edge of the capacitor where the aluminium can comes down and crimps around the bung in the bottom. And then they're all glued together, taped together, and then there's an insulating sleeve or insulating sheet that goes down between the 2 rows of capacitors, because they're at different potentials, because it's a mid-bus between the 2 capacitors in series. So the bodies of each will be at different voltages, separated by nearly 400 volts. So anything not very good about it is that this glue just peels off. Doesn't want to adhere to the body of the caps at all. It'll probably be fine though. Once that tape's around it nice and tight, it's not going to peel off. It's not going to go too badly. Just like ungluing stuff. Yeah, those caps are wrecked now because I've stressed the terminals by prying them a bit. As soon as the cap's gone wobbly, it's wrecked, because it would have damaged the little seal in the bottom where the terminal goes through that rubber bung thing. Once you've done that, it's wrecked, because it might work now, but it's going to dry out very fast, because it can escape around the broken seal between the leg and the bung. Yeah, so these high frequency transformers must get fairly warm, because I've wrapped them in copper, and then that was quite well bolted down to this bottom heatsink plate. Pretty interesting there. I wonder if this copper is just sitting on them. It isn't just sitting there. Of course it's not. There's nothing squashing it on. I think it's some thermal adhesive. Yeah, it's hard. Thought that might be just paste, but no, it's an adhesive little solder link thing holding the capacitor down. Was that joined to anything? It's just a ground thing. So we can probably find out what What is that capacitor? Just for fun. So that is, well, it's probably a 35 volt 470, more than 470. 35 volt 2200 microfarads, so that's the primary bulk electrolytic output capacitance, but it's just getting the big chunks because all the high frequency noise is going to be taken up by these ceramics, which must be very high performance ceramics since they were heat sunk down through those pads. Quite surprising and interesting. See, there's a current shunt there, B for measuring the output current, and then there's those high current transfer points onto this front board through slots in the board with plating and quite poor soldering. It looks alright on that side. So there's a tab on this vertical board which has plating on both sides of it to solder onto, and then in this ring around the slot there's wires through there to help the solder flow through. But if you look from this side, barely flowed through on that one. That's interesting because should that have passed inspection? It's probably sitting at a pass for the worst. I don't know what the IPC standard is, but there's 3 levels for acceptability of soldering depending on how far the solder flows through the holes. And yeah, if you want top quality, you're looking for a proper solder meniscus on both sides of the board. But if you're looking for just average generic stuff, then it's allowed to only flow through sort of 20% or so of the holes, which looks like what that is. It's not that good. It looks like it's been selective soldered. You can see because there is a trail around there and some tied lines. Yeah, or maybe not. Maybe it's had a, what do they call that thing? A pellet? A solder pellet? Not sure, I can't remember what the name is, but you put this shaped thing gets put over the board to cover up the parts you don't want the solder wave to flow onto. Then go through a wave soldering machine and the solder will flow into all the other parts. I'm not sure whether that's done that way, because you can see definite boundaries around these bits where there are through-hole parts that were soldered. So they're protecting the surface mount to not touch the solder wave, but then exposing it to where there's through-hole parts. So one way you do it is, as I said, there's a thing that fits over there and blocks off the surface mount parts and parts you don't want solder flowing onto. And the other way is using a selective soldering machine where it has the board's just sitting there and it's got a movable nozzle which squirts out solder of a certain diameter, and it's like pretty much just the tip of a fat pen, marker pen kind of thing, and the solder comes out from the center and flows down the side, and that then drives around the various sites that need to have soldering done to them, like where there are through-hole parts, and then it can withdraw and move to a new place and then start squirting out solder again. Selective soldering, it's really good when you got surface mount parts on the bottom side which can't go through the wave, or you don't want them to, but you still have fairly beefy through-hole parts that need doing. Much easier than getting them hand soldered. And on the front edge, so we've looked at some stuff. The AC comes in through there, transfers onto this board, some stuff happens, comes back down through these transformers, now it's low voltage, rectifiers, high current output, comes across through board to board connection there, and then on this final part, it's quite interesting that they shielded off the AC section from the rest of it. Oh, that was on the other side quite well. I guess because that's the noisy bit before it goes through the clamps and filters. So it comes up, got this quite grunty common mode choke, noise suppression soldered on there. This board here is interesting because there is flux residue visible on some of the parts. The rectifier and some of the caps. I wonder why that is. So it looks like this whole board, this front board, should have been wave soldered. You can tell that because the few little surface mount parts that are on there, you can see have got glue blobs under them. So use the things similar to the solder paste stenciling to put blobs of glue where surface mount parts are going to be put. Then it'll go through the surface mount placement machine and just get the parts placed into those glue blobs, and they'll sit there, and then that will hold the parts in place while they get flowed through the solder wave. Again, it looks like some parts have been masked off from the solder wave. See, there's no solder penetration in those wires there, so that was masked off around and around there. The reason why it's different there will be because of the, before going through wave solder, flux will be sprayed over the whole surface of the board, and then when that gets heats up and activated, it will leave that sort of different looking residue stuff on the surface of the board, and it hasn't happened there. So definitely some parts have been masked off from the solder. I'm talking about manufacturing stuff because that's what I know more about than the detailed electronics of how it works. Yeah, so what we were saying is common mode choke up here, then some final capacitors, and then the output terminals, which they give you 3 grounds and then 2 positive, and then some final little token gesture output caps, probably be some like 35 volt 4.7 mic or something like that. Just thinking about what sizes are available in that type of cap. Depends how crappy you want it to be. Here's a reel of Murata. They're X5Rs, see, so they're not so good. 16 volt 22 mic X5Rs. But I think those are bigger than that. Like 2220 type packages. And then there are other bit up here is some control stuff, but we can't see it. We'd have to take that out. Get rid of this so we can see those ICs because they're part of this. It's not a separate control board, it's part of that main board. You can see there some IC in there. There's the trim pot for adjusting the output voltage, power OK, and the boost active LED. Then there's another IC. Oh, look, we can bend those things out of the way. It's an ST7FLITE39F2M. It's probably a microcontroller, and that might be a flash memory for it. And then those two things there, I think those are input buffers, because this thing has got some kind of input or output doofies on there. It's got a relay contact thing, and then maybe it's an enable IN current normal DC OK. So I think it can signal when it's being overloaded and signal when it's okay, and then some kind of input. Look at that. So that will be some kind of optocoupler thing there for the input direction. This is one of those high creepage optocouplers. Maybe it's an integrated input thing. And then there's clamping to ground on those input terminals for noise and static discharge. Okay, I thought what we were going to do is compare it to that other power supply. Guess we didn't do that. Let's do that quickly. The much smaller Quint power. Some things are similar. Don't think it's such high frequency though. It's a similar situation where AC input, filtering, rectifier, 2 lots of PFC boosting chokes, so that's equivalent to that stuff there. DC bus, similar arrangement with, although in this case are they in parallel? Okay, so it's running from much lower DC bus voltage, which makes sense if it's a single phase input. It'll be only around, be boosting up to about 400, and like this one it will be going to near 800, which it has to because the rectified AC input from 500 volts AC is pretty high, so the DC bus voltage has to be higher than that for the PFC booster to work. Then that comes across, and then again there's another thingy. I guess that's the resonant inductor, isn't it? If it's a resonant converter. Oh, I guess that's what that is then. because it said res cap, which would be those things, so I guess that's the resonant inductor. Does that make sense? It makes sense then that why there would be just one little pin joining that section over. There would be one leg of that inductor. I don't even know where are the terminals of the inductor. I think it's that and that. Presumably then that's the L from the LC resonant circuit, similar to what this will have, which is L and some C's, simulating having a gate drive transformer like what that's got down there. And then the output, there's some rectifiers, which again looks like synchronous rectifiers with little control ICs, some output caps, just electrolytics in this case, and then common mode chokes, final output caps, and then outputs. Okay, well, there you are. Hopefully that's an interesting look, teardown, sloppy investigation of this Quint-PS PS3AC24DC/40. And it's 40 amps, 24 volt output, 3-phase input, DIN rail mounting power supply. Come from the scrap bin for our enjoyment. See you next time.